everyone, this is Dr. G. Amarnath, Associate Professor and Dean IIC Mlritm from Department of ECE. I am presenting the Analog and Pulse Circuits course. Regarding this subject, the introduction of this course we will discuss now. In this course, now we will go with the overview of this course and syllabus and applications and real world applications where we are concentrating about this course. So in this one, the first, what are analog and pulse circuits? So in this one, first analog circuits, pulse circuits, both we will study in this course. First one, the analog circuits, they deal with the continuous signals. Continuous signals, like here we are having the amplitude with respect to the time. One signal continuously it is changing, and it deals with continue. So now we will go with the analog and pulse circuits. So here, what is analog circuit and pulse circuits? First, in the analog circuits, we will deal with the continuous signals, where for the circuit we will apply the continuous input signal, like here the sinusoidal signal with respect to the amplitude and time. With respect to the amplitude and time, the continuous signal will come. It will vary continuously, it will vary with the time. And also the sound examples are for this sound, light intensity, and also we can deal with the these circuits process real world data for amplification, filtering and modulation. Like examples we are having with the analog circuits, like microphones converting sound waves to the electrical signals, audio amplifiers in our homes, and also we are having the another one, the pulse circuits. In the pulse circuits, it handle the discrete signals like square waves, triangular waves and sawtooth waveforms. These signals will give the input for the circuits. So some of the examples for this, the traffic light using pulse circuits for LED timing. So whenever we are going through the traffic signals, the traffic signals will vary with after a duration of after the some pulse duration. So whenever we are triggering the pulse, it will change the signal from the red to green or green to yellow, like it will change the signals. And also oscillations in digital clocks. Like here we are having the pulse signal, it's like in a square wave signal, and also even a single triggering pulse we are applying here. In the pulse circuit, we will apply the square wave signals. Square wave signals, it is having the high level and also a low level, with two levels of the signals we are having, and also it is a continuous square wave pulses we can apply to our circuits in the pulse circuits. And also we can apply a one single pulse as in a one single triggering where it is required. There we will apply the single pulse signals. So why study this course, analog and pulse circuit course? So this one we can use for foundations in electronics. Like in our earlier semester, we have studied the electronic devices and circuits. In that electronic devices and circuits, there we have studied the basic devices like PN junction diode, BJT, MOSFET, and using that BJT and MOSFET we have derived the amplifier circuits. So now that amplifier circuit we will take into the applications, and we will design some circuits like oscillators, feedback amplifiers, power amplifiers, class A, class B, class C amplifiers. Even using the pulse circuit we can design the multivibrator circuits. So the foundations for the electronics, that integrated analog and pulse circuits, and we can use in communications, automations, healthcare and consumer electronic circuits also, like TVs, remote controls, voice recorders, sound systems, voice recorders, and everywhere in electronic consumer applications we can use our electronic circuits. And also from audio systems to radar technologies, we can use as in a practical impact on using these pulse circuits and analog and pulse circuits. Like here some examples, analog circuit amplified the sound in hearing aids. Like example, when we are using this hearing aid here, that aid is designed with our LM386 circuits. So in that circuit we are having the basic components like transistors. Using those transistors we can design the amplifier. Whenever we are giving the sound signal, that sound signal will be amplified and it will give it to the human ear by using the hearing aid devices. and pulse circuit generate the precise timing in medical ECG signals. Like here, when we are taking the one ECG signal, that ECG signal by using this pulse circuit generate the precise timing in medical ECG machines. Like here, we are using the one controller. In that controller, we are having the one electronic circuit. That electronic circuit, it is having the pulse circuits. That pulses, when pulses are generating here, it is giving the signals and it produces the ECG waves. Like here, these signals will generate by using the pulse circuits here. So coming to our course syllabus, in that course syllabus we are having the 5 chapters. These 5 chapters covering the total analog signal, operator circuits, and pulse applied inputs. Pulse is applied as an input and generate the signals like square wave, triangular wave. Those signals will be generated here. So in that one, the first unit is the multi-stage amplifier and high frequency transistors. In that high frequency transistor, there we can, when we are applying the high frequency signal as our input signal, how that amplifier will be react and what are the effects will come. Those signals will be analyzed when you are applying the high frequency to our amplifier circuits with hybrid pi model, and we can analyze the frequency response. Even when we go with the multi-stage amplifier, there we can study the different types of the multi-stage amplifiers, how it is coupled from one stage to the other stage. Like in the electronic devices and circuits, there we have studied the single transistor based amplifier circuit. So with that single transistors, like here, there we have studied the one, there we have applied the input. Here we have applied the V in, V out we will consider by taking the Q factor of the transistor. So when we are connecting these output to the next transistor, here another VCC we will apply second CE transistor. Here we will take the final output here. In that final output, there we are having the Q1 and Q2 transistor of the output signal. Suppose if here we are applying the input is 5 volts, and we may expect the output, as it is an amplifier, as it is an transistor acts as an amplifier, we may expect the some 7 volts of the output. Again, that 7 volts of the output will be connected to the Q2 transistor. Again, the transistor having the amplification, so that we can expect at the output it may around 9 volts we can expect. So by using these two transistors, when we are applying the input is 5 volts, it is giving the some 9 volts of the output. So this is the advantage. To increase the output, we will go with the multi-stage amplifiers. So these things, the different coupling scheme, and also when we are connecting this transistor, first transistor to the second transistor, so how we are connecting here, that is the coupling methods, different coupling methods we will study. And also when we are taking the output and these couplings, the distortions may occur, like so how we will eliminate the distortions and what are the types of the distortions will come here, those things will be studied in the unit 1. Coming to the unit 2, like here we are having the feedback amplifiers. Unit 2 is feedback amplifiers. In that feedback amplifiers, here in the previous example, like here, unit 2 is feedback amplifiers. In that feedback amplifiers, like in the unit 1, multi-stage amplifiers are there. In that multi-stage amplifiers, there we can consider the first stage, and the first stage output will be given to the second stage, and like others, for the nth stage we will apply the input and there we will take the output. So instead of taking all these stages, the feedback amplifier, like here, the first stage of the output directly will give it to the input of the first stage. So at this time there is no need of these stages second stage and so there is no need of the second stage to the nth stage. These stages are not required, because here the first stage of the output directly given to the first stage. Again the output will be amplified here, amplified output will come here, again it is giving to the first stage, again here it will be amplified, and again the amplified output will come. Continuously it will repeat when we are taking the feedback. So now by using this feedback amplifier we can reduce the complexity of the circuit and we can get the more output. But here in the feedback amplifiers in the unit 2, there we will study about the negative feedback amplifiers. In the negative feedback amplifiers, there in the unit 2 we will use the negative feedback amplifier. There we can study the different types of the feedback amplifiers, that is the negative feedback amplifiers, and when we are using the negative feedback amplifier, how the characteristics will change and what is the effect of the bandwidth and how frequency responses will change, the characteristics will amplifier characteristics we will study with respect to the negative feedback of the amplifiers, we will study in the unit 2. Next, coming to the unit 3, there we can study the oscillators. The oscillators, here we are having the different types of the oscillators like RC coupled RC type of the oscillators, LC type of the oscillators and crystal oscillators. These oscillators we will study and we will analyze in the unit 3. So in that oscillator, that is the one type of the positive feedback amplifiers. Positive feedback of the amplifiers we will study in the oscillators. Comparison to the unit 2 and unit 3, in the unit 3 negative feedback, in the unit 3 positive feedback amplifiers we will study. There, like here in unit 3 oscillators we will study the RC type of the oscillator, LC type of the oscillators and crystal oscillators we will study, and we will analyze these oscillators mathematic, and also we can calculate the frequency of oscillation or resonant frequency and how the frequency are changing and the characteristics of the amplifiers we will study in the unit 3. Next, in the unit 4 we are having a large signal and tuned amplifiers. So large signal, like it's in a power amplifiers, there we are having the different types of the power amplifiers we will study here, like one is the class A amplifier, class B amplifier, class AB and class C amplifiers we will study. These amplifiers are categorized based on the Q point position of an amplifier with respect to output characteristics. When you are drawing the output characteristics for an amplifier, there we will consider the Q point. Based on these Q point positions, we can classify the amplifiers as the A, B and C amplifiers. These amplifiers generally, when we are applying the large signal, like the amplitude is large, the large amplitude signals we can apply to these amplifiers, so that how it will be changed. So how Q point positions are changing. So for that, according to the Q point positions, we can design the circuits and we can classify as the different types of the power amplifiers, and also we can analyze the efficiency, that is the output power by input power we can calculate, and we can calculate the efficiency of the power amplifiers, and also we can design the tuned amplifiers. With the tuned amplifiers, when we are changing the frequency at particular frequency, it will tune to the particular channel, like example FM radio station. In that FM radio station, we can tune to the particular frequency and we can listen the one channel. So that type of the circuits we can design in the tuned amplifier circuits. Next, in the unit 5, that is the multi vibrators and time based generators. So till unit 4 we can use the analog signal as an input signal, and in the unit 5 we can use the input as the pulse signal. By applying the pulse, we can generate the square wave or triangular wave. These signals, pulse signals, we can generate by using these multi vibrators and time based generators. These signals will vary with respect to the time, and how the time signal will be generated, and also the multi vibrators, how it will be change the signal. Here multi means many and vibrator means vibration giving the frequencies. So many frequencies will generate by using the multi vibrator circuits. So these circuits, like a stable multivibrator, monostable, bistable multivibrators, even some Schmidt trigger, time based waveform generators we will study in this unit 5. So here some of the highlighted points from this course, analog and pulse circuit, that is the amplifiers we will study. That amplifiers are the multi-stage amplifiers, and also we will study the feedback amplifiers, power amplifiers. These type of the amplifiers we will study, and these signals we can use in some communication systems or signal processing systems we can use. and also oscillators, that is the positive feedback amplifier. These are the essential for the waveform generation. And also the feedback system, that is the positive feedback and negative feedback, these amplifiers we will study here. So these are enhances circuit stability and performance. Even we can calculate these performance and stability of the amplifier circuits, we can calculate and analyze in our course. And also the last unit is the time based generators. Using these time based generators, it is required to creating the precision timing signals is required. So for that we have to generate the time based generators. So in this course we are having the course objectives are the to understand the design concepts of multi-stage amplifiers and also design concepts of transistor amplifiers at high frequency and concept of feedback in amplifier circuits, design various multivibrators using transistors and sweep circuits, to analyze different types of oscillators and large signals. These are the some of the objectives we are having in this course, and by these objectives the students can learn and also they can able to do the analyze the different types of amplifiers operation and they can analyze the operation of the circuits and its characteristics, understand the concepts of feedback in amplifier circuits, study different classes of power amplifiers and tuned amplifiers and transistor amplifier at high frequency using some hybrid pi model concept, and multivibrators and applications by using these multivibrator and sweep circuits. And also these course having some learning outcomes, the students can learn from this course and they can able to understand basic analog and pulse circuit principles, analyze feedback effects, stability and frequency response, design amplifiers, oscillators and multivibrator circuits, and apply their knowledge to practical devices like radios and timers they have to design, and evaluate performance using the real world metrics. Like here, whenever any practical example circuit is given, example like generate a circuit to generate the frequency of 100 megahertz. For that which components and circuit we have to consider and what we have, how we can develop that circuit, that can be do by the students at the end of this course. Some of the real life applications here, generally we can see day to day, like audio systems, amplifiers in speaker and hearing aids. There we can having the amplification system. So that amplification system, like here one example, if you are talking through mic and by controlling this it will be comes out of the with large sounds. And telecommunication systems, there we can use some oscillators in radio transmitters, like here radio frequency oscillator we can use to generate the like in a frequency, stable frequency. It acts like in some carrier frequency that is given to the modulator, and in the communication system in the transmitter we can use these oscillators. And also healthcare systems, ECG machines and ultrasound devices, there we can use some multivibrator circuits we can use. And automotive ignition systems and radars, like here any car we can control, like when we are pressing the key the doors will open, like controlling system can be possible by using these electronic circuits. And also some consumer electronics like digital clocks and monitors, TVs, LEDs, these can be for these we can design the circuits based on our circuit components. From here we can design. And also another real time examples like mobile phones. In the mobile phones we are having the amplifiers for voice clarity during the calls. Like if it is the good amplification is there, the voice will be clear for the both for the transmitter and reception. The voice is very clear if the amplification is there without any noise and disturbances. And some watches like digital watches, it is required the crystal oscillator for accurate time keeping, like wristwatches or any computers, like even the computer is in the shutdown mode also. The when it is in the shutdown mode, even if you turn on after the 1 hour delay, then at that time it will show the updated time. That is possible by using these oscillators. And also pulse circuits for detecting the object, like any radar. In the radar systems, any object is detecting the triggering. Now detecting acts like a triggering pulse. When it is triggered, the circuit is getting the signals and we will get the output. There we can find the radars by detecting the signals. And traffic lights, we can use the multivibrator circuits. In that multivibrator, monostable multivibrator, astable multivibrator, when the triggering pulse is applied, the signal will change, like red to green, green to orange, like the signals will change. And in the wireless communication system, oscillators for signal modulation, like in the previous example, like here we can use in the wireless communication systems also. And one of the example that is considered from this source, that is the phase measurement method. In that phase measurement method, here to detect a to measure a one phase signal of given input signal, here input signal is the analog signal, and also there we are giving the some pulse signals. These pulse signals, when we are giving the pulse signal here, it gives the sampling circuits. There where it is triggering, there we can calculate the phase of the signal. So like here, to calculate the phase in the continuous time domain, in the continuous time signal, if you want to calculate the phase here, there we are applying the one triggering pulse, and there we can calculate the phase. In another time, here if you want to calculate in this continuous signal, analog signal, we are applying the triggering pulse at this moment, there we can calculate the phase of the signal. Like here in this circuit, both analog signal and pulse signals, both we can use here in this to generate the phase measuring. In this in this circuit, we can use both analog signal and pulse signal to measure the phase of the signal here. So both analog signal and pulse signals are required to generate the electronic circuits for the different applications. So for this course, we are having some textbooks like here, Electronic Devices and Circuits by Millman and Hackes, and this one is a very standard textbook. The most of the syllabus will be covered from this textbook and all. And another one, Pulse, Digital and Switching Waveforms, the unit 5 will be covered from this textbook. And also we are having some reference books, Electronic Devices and Circuits by Shalivahanan, and Op Amps and Linear Integrated Circuits by Ramakant and Gaikwad, and Solid State Pulse Circuits by David A. Bell. These are some of the reference books you may follow. Even we are having some electronic resources like NPTEL courses are there on this subject. One module, each module will cover in a different different courses. In different courses, each modules will be covered. So this by using this course, at the end of this course, you can able to design a one amplifier circuit. With that amplifier circuit, you can design for a desired frequency or less noises circuits you can design by using this course. Thank you.